This tutorial is for educational use only. It is not authorized nor approved for any other use.
Alrighty, it's time to continue this party. We are going to build the function that is going to allow the smart contract to mint staking rewards tokens, okay? But it's tricky. It's tricky because, again, we need to know how many tokens do we need to mint. And when I say mint, the Masterchef smart contract is going to send the request to the staking reward token smart contract, the ERC20 token smart contract, to mint X amount of tokens, okay? So for that, I have to do the following. I have to determine how many tokens I need to mint based on, number one, the pool allocation. And I think one of the most important things in the Masterchef smart contract is going to be the last reward block value. Refresher, the last reward block value is that block number that we are going to be storing in the Masterchef smart contract every time there's an action. Either someone stake tokens, unstake tokens, compound. They don't want to necessarily unstake. They just want to grab what they had, stake plus the earnings, and combine that and restake those tokens. So whatever they earn, in the case of the N to the R token, let's build pool 0, which is going to be the N to the R token. You stake N to the R tokens, you earn N to the R tokens. When I do auto compound, the moment I earn N to the R tokens, I can just grab whatever I earn, I can throw it back in the staking pool. So that's auto compound. Every interaction with a staking pool, we will take the opportunity to record the last reward block, because that's going to tell us how much time did we have since the last reward block, and now to determine how many tokens do we have to mint, okay? This is not the only parameter that we need to identify. We also have to identify how many tokens are staked in the pool, okay? Because with that value, then I am again determining how many tokens I need to mint, so then I can provide the reward per share. I have one stake token. I am going to receive X amount of reward tokens for every single token that I staked. You got that? So, having said that, what we are doing in this video, we are grabbing, I'm going to say 75% of the DeFi staking math in the Masterchef smart contract, and we are going to configure that function that is going to allocate the tokens to each respective pool, okay? It's very important, this video right here, because we're going to be working with the math that is going to make the magic happen. On the next video, we are finally building the unstake and stake functions, okay? In that video, we are building the final functions, and we should have the Masterchef smart contract ready to go. And I told you, I am breaking the Masterchef smart contract with detail, so then you understand how everything connects. Because this smart contract is not your ordinary NFT collection smart contract. There's a lot to it, okay? And I want to make sure that the tutorial covers everything with a lot of detail, okay? So let's jump into the whiteboard session. We are going to be breaking the updatePools function very, very detailed. We'll do the math, we'll code, we'll write it up, we'll send it to the smart contract, and we'll go from there. Let's go ahead and build the updatePool function, okay? First thing we are going to do is initialize the function by calling the pool ID. So every time that we want to update the token allocation for X pool, so any pool, we are going to be passing the pool ID, okay? So let's say, for example, I am going to be updating pool ID 0, which is the first pool ID that we deploy once we deploy the smart contract, okay? I am going to be passing pool ID 0 here. Here's the thing, anytime that I need to interact with a staking pool, I need to make sure that I, one, update the pool. So this has to be run first. And second, I need to make sure that the pool that I'm calling, that I'm passing as the argument here, right, as the parameter in the function, has been created in the smart contract, okay? So for that, I need to validate that the pool exists, not only the update pool, but also in the other functions. And you might already be telling yourself that, okay, this is no problem. All I have to do is I am going to be doing require, and I'm going to say, well, if PID is lower than pool info length, right? That tells the smart contract, hey, if the pool ID that you're passing is less than the length, obviously the total amount of pools is going to be the max number, right? So we want to make sure that our value falls before or below the pool length. So with that said, I will have to do this, which is basically validate, right? This doesn't match or this is not met, then say pool ID invalid, right? And we're just passing that require to do that checkup, okay? That works, but I will have to copy and I will have to add this to every single function that I need to validate this. What we can do instead, and this is on the Masterchef smart contract, is to write a modifier. What the modifier is going to do, it's going to basically call this particular action. It's going to make this particular call, and then it's just going to continue executing the code. Check this out. So what I'm going to do, I'm going to say the following, right? We're going to build this modifier. Then we're going to be applying this modifier across all the functions that I need to. Imagine that this is like the section in the smart contract where I have all my functions. Before that, I am going to be adding that modifier. So we are going to initialize the modifier by doing modifier, and we're going to say, let's call this validatePool, just like the Masterchef smart contract. And we are going to now pass the same value, which in this case, it's going to be that PID value, because what I'm going to be doing in the function is just passing that call, okay? So we're doing that call up to the modifier, then the modifier will have this requirement right here, this statement, okay? So what I'm going to be doing is I'm going to be passing this inside the modifier. Let's put this a little bit down here. With that said, now I can effectively do this. I can, open my bracket, and then I'm going to say here, now what I want to do with this, right? This will be the name of the modifier, validatePool. I'm going to be passing the pool ID. I'm opening bracket and inserting the requirement. What I can do in Solidity is I can do it in underscore colon. What is that going to do? Okay, and let me go ahead and close the function. Okay. So what this is going to do, it's basically once I apply the modifier to the function, I am basically telling, look for this particular or read this particular statement first, then just continue with the rest of your function, what is going to be coded below, okay? That's very cool. Now that I have this and this is ready to go, all I have to do is I have to use the validatePool. And I'm going to be declaring this. First of all, I have to make sure that I declare this function to be public, right? Because we're going to be using this function outside of the smart contract as well as inside. Now I can invoke the validatePool. I can insert and I can attach the validatePool here. I'm going to say validatePool, and I am going to be passing the PID, okay? You see, that's cool. Now I can effectively just continue my code. I'm going to just continue here. By the way, I should do this black so you're not confused. So what I'm going to do here, right, I'm going to just add this here. I'm going to say public, validatePool, and I'm going to just pass the PID. And there you go. Beautiful. Okay. Now I don't need this. Okay. What I'm actually doing, check this out. This is super cool, and this makes the code a lot cleaner. So what I'm going to do here is just pass the value, then I'm going to be calling the modifier first, right? I will be inserting the value as well. I'm going to be passing the value here, and this value will be passed here, right? So let me just mark it here. I am passing the PID once I make the call. Then that value, it's then used here, and then I'm going to be invoking my validatePool, okay? I run the modifier. Once I run the modifier, what will happen, the require will be checked. I am going to make sure that it falls in the range of the pools that I have available based on the value. Then it's just going to continue with whatever the function has written. Okay, so in this case, this is checked first, and then it just continues with this particular section right here. It's telling, hey, just continue executing whatever you have below on the function that we attached this, okay? So now we have the validate pool and we were able to attach this. We have everything good to go. Now what I want to do is the following, because we're going to be working with the pool ID on this particular pool. I have to do the mapping. So I have to map the storage. I have to build that variable that we are going to be using across the entire function to interact with a particular pool. So I'm going to say pool info, and then I'm going to go and pass storage, right? So now by calling storage, then I can label this to be pool, and this will be the variable that I'm going to be using. And then I'm just going to be invoking the struct. If you are still in doubt with this particular section, go ahead and watch video number 3, and I go in detail on this, okay? Awesome. So pool info, and then effectively I'm just gonna pass the PID, right? So we're just gonna pass the PID, and okay, awesome. So now that I have storage pool, I will be using this to do my calls, okay? I'm going to be invoking pool across all the actions that I'm going to be doing in this function, okay? So the first thing that we have to work with is the last reward block. And we mentioned that the last reward block is the block number that we are going to be recording every time that we do a transaction with any of our functions related to the staking. Okay, so we want to make sure that whichever action we did with one of those pools, we recorded the last reward block, which means that that moment on, we did XYZ on X function, okay? I have to make sure that that number is lower than the current block number, okay? And why is that? Why is that? Is because the last reward block has to be less than the block number, okay? So this value must be less than the block number or the current block number. So let's say the last time we made a call to the smart contract and it was under block number 465321, something like that. I have to make sure that this value, ladies and gentlemen, has to be lower. This has to be lower than the current block, okay? Or else, why do I even need to make this call? That means that it's already updated. And again, this is in the case that we had two transactions, and the first one tried to update the pool, did the update, then the second one wanted to do the update as well, but we don't need to do the update again because it was already made, right? It's when we have one number that is higher over the last block, then we go ahead and do it, okay? All right, so let's continue. So with that said, I have to add that. So we're going to take a look and make sure that if the block number is less than the last reward block, we don't need to run this. So what we're going to do, we are going to update this pool to run this function as long as the block number is higher than the last block. So let's go ahead and do that. I am going to be adding an if statement, right? If block number is less than pool, because we're calling a particular storage, we're working with a particular pool, last reward block. This will be the value that will be stored in the pool struct. And if that's the case, if this matches, then what I want you to do is return. I want you to stop the function from continuing. So this will be the first condition that we are going to be checking. The second condition, we have to make sure that there's staked tokens in the pool. First, I need to get the liquidity pool supply, or the amount of tokens that I have available in this particular pool. To determine if it's higher than 0, then run. Okay, if it's 0, then you don't need to run the update pool, okay? We are going to declare another variable, calling this LP supply, okay? This will be liquidity pool supply. And now what I have to do, I'm going to be calling my storage, which we already mapped, and we're going to say pool. Now we are going to be calling the token smart contract that we are allowing to stake those tokens here. This is going to be the reference to the smart contract. Now I can make calls into the token smart contract, and we're just going to be passing balance of. This function is going to give us the balance. And what address do I need to check? the smart contract, this smart contract, the Masterchef smart contract, okay? So we're gonna say address, and we're just gonna pass this, okay? That way, we are effectively calling the token smart contract, and we're asking the token smart contract, hey, give us the balance of this particular address, the Masterchef smart contract address, and we will have the value here. Now with this, I can make that condition. I can say, if liquidity pool supply is equal to 0, what are we going to do? That means that there's no tokens staked. We're going to be doing the return, but before that, I am going to be updating the last reward block, because we did a validation. We checked something, and it turns out there was no stake tokens, but we still want to make sure that we have a record of what was the last time we ran this update pool, and we record the block number. So what I'm going to do is pool last reward block. This is going to be the storage, the mapping to the storage. And we're just going to be passing what? The current block. So we just say block that number, and that's it. That's how we store the value of the current block when we call this function. And then I can effectively say return, and we are done with the second checkup. Okay, awesome. So this is how it starts, right? But this is not all. We are going to be simulating a particular pool, and we're going to be doing the entire math piece by piece. The multiplier, the token per share value, the amount of tokens per share equals, the amount of tokens that I'm going to be receiving per stake token. Let's do all that. What I'm going to do is I am going to head here. I actually prepare this for you guys, for everyone. I am going to be breaking this apart. So what I'm going to do, I am going to imagine that I have two pools. I have pool 0 and I have pool 1. This is the token that I'm going to be allowing to stake on the pool. And this is going to be the token that I'm going to be paying the stakers. The second pool has USDT as the stake token, and we are going to be paying with the N to the R token, okay?
First things first, the update pool is going to work with the following values. Be executed at block number 42,63376, okay? The smart contract has been set with a block multiplier of 2, okay? We mentioned that we have 10 tokens per block, meaning that every block we're going to have 10 tokens mined or minted, okay? And we have a total allocation of 1,000, which means that every pool will have a value, an allocation value, right? That means that if there's 6,000, then, we have pool 0 with 1,000, we have pool 1 with 2,500, we've got, and many other pools with different values, and the total allocation in that case is just going to be 6,000, okay? So with that said, first thing that I have to get and I have to obtain is going to be the multiplier. The multiplier is basically grabbing the block number, and we are going to be subtracting that block number against the last reward block, okay? Then we will multiply that value against the bonus multiplier, which in this case is going to be 2. Let's build that formula. So we mentioned we are going to be calling it multiplier, right? And we mentioned it's going to be block number minus last reward per block. Then we will multiply this. I put it over here. We are going to be multiplying this by the bonus multiplier. With that said, I have to obviously resolve this first. I have to calculate this first, and then we will just multiply by the bonus multiplier, okay? Let's say that the last reward block that we previously got, 42,63244, okay? So what I'm going to be doing is I am going to be replacing those values with my values for here, okay? So let's do this. Let's grab this, and I am going to be grabbing my block number, okay? We're just going to pass it down here. And now I'm going to be replacing last to our block. Pass it down here. There we go. And we are going to be multiplying this by 2. As we mentioned, that's the bonus multiplier. Okay. Now let's solve this, and we should obtain the multiplier by it. So let's do that. 42,63376. Okay. Minus 42,63244. We end up with 132, and we are just going to multiply this by 2, and that will be our multiplier, okay? So that means that we have a total of 132 blocks, okay? We're multiplying this by 2, so because we're giving that bonus, it's going to be 206. Okay, so now we have the multiplier, which in this case is going to be 264. Beautiful. Okay, we got the first value. Now we obtain the multiplier. Now we have to obtain the token reward. Okay, this will be the amount of tokens that I'm going to be allocating, and I'm going to be minting, sending to the smart contract so that we can provide the tokens to the stakers. Okay, let's do that. So now I'm going to be obtaining the total reward. And then how do I obtain that? And this was video number 1. Okay, I have to first pass the multiplier. Okay, and we are going to be multiplying this by the n to the r per block. Okay, or in this case, it's going to be the token per block. This is the amount of tokens that I'm going to be mining or generating every block process. Okay, and now we are going to be multiplying this once again. This time it's going to be with the pool allocation. Okay, awesome. So we have that. Okay, now once I obtain that value, I am going to be dividing this against the total allocation, which means it's the sum of all the pool allocations. Every staking pool, we will have a pool allocation. Okay, the sum of all the pools, it's the total allocation. The pool allocation 1, 2, 3, and 4. Awesome. So let's go ahead and replace those values. We're going to do it here. I'm going to add this down here. We're going to go ahead and replace that. Now we know the multiplier is 264. We obtained that before. Okay, so 264 into the upper blocks. And remember, we are working with a way. So this is the way value. So this is going to be 10 to the factor of 18. That's going to be the way value. Okay, let's say into the upper block. I'm going to add this down here. Now I am going to be passing the pool allocation. And remember, we're working with pool 0. Okay, so we're working with pool 0. So let's do the pool allocation. This is 1,000. I'm going literally step by step here. Okay, and finally, the total allocation across all my pools. In this case, it's going to be 6,000, as we mentioned on the beginning of this section. Okay, now what I have to do, I have to first of all resolve. We're just going to multiply 264 times 10 to the factor of 18, 1 to the factor of 18, and then we're going to be multiplying this by 1,000, then dividing the total by 6,000. So, okay, let's grab the calculator and let's do it again. Okay, so let's go ahead and do the formula. So I'm going to multiply 264 times 10 to the factor of 18. This is the way value of 10 tokens. And then we're going to multiply this by 1,000, okay, which is the pool allocation for pool 0. And then we are going to divide this by 6,000. Okay, we end up with 440, right? And this is in way. I am pretty sure that this will be 440 even, or for 440 tokens, right? So with that said, we know that we have 440 tokens that we have to mine and we have to send into the staking smart contract so that we can provide the rewards to the stakers. Okay, and the supply, and I didn't mention this in the beginning, but the supply in this pool, which is basically the amount of tokens that I have on the pool stake, 679,924. Okay, now that I have that value, now I know that the total reward, it's going to be that amount, 440. Now we have that value. Awesome. We have to find how much do we have to pay the developer. We're going to be adding the developer fee. We have to pay the developer, and by paying the developer, what we're doing, we are minting a set of tokens, an additional supply of tokens, and we will deliver those tokens to the developer address. The address, we configure that address at the beginning of the video. We add that address as soon as we deploy the smart contract. So with that said, I have to obtain the fee. If we are going to be paying the developer 10% of every time that we mine tokens, then all we have to do is we are going to now invoke developer fee. We're going to be declaring developer fee, and all I have to be passing is token reward, and we will be dividing this by whatever percent. So if we are going to be providing 10% to the developer, then that basically summarizes in 440 and divided by 10. Now the developer basically is going to be receiving 44 tokens. This is literally the 10% of 444. 40, 10, 44. okay? The amount of tokens that we are going to be paying the developer for this particular set of blocks. The last thing that we have to find out is going to be the reward per share, okay? So we need to determine how many tokens am I going to be paying per each stake token, in this case, the liquidity pool supply. We already obtained the token reward. All we have to do is build that final formula that is going to give us that information, okay? So let me just copy and paste, because I love to copy and paste. And now what I'm going to do is the following. I'm going to say allocation token per share, and this will be equals to, remember, we are assuming that this function has already been called, which means that this value, again, those variables are actually populated with values. It's stored with data. It has data already. It's data that has been stored in the smart contract. We are actually updating that data, which means that this must already have some value. We have to make sure that we keep the value, then we add whatever or subtract whatever case, okay? So in this case, I need to obtain what was the value once again. So in this case, I'm going to recall that again. I'm going to call that a value. Okay, I'm going to say account token per share, and we are going to be adding account token per share to what? Okay, check this out. To token reward, but then the token reward, we have to convert this into a Zabel. So Zabel, it's another unit in Ether. So in this case, let me show you. So if we go into the full converter, we are going to be adding a factor of 12 to the amount of tokens as the account token per share. Okay. So with that said, let's go back and we are going to say the following. We are going to be multiplying this by 1 to 12. Okay. Which means that I have to solve this first before I can even add that to the other values, okay? Which means that I'm going to add another parenthesis here and make sure that we only solve this first before we can move forward with the other calculations, okay? And now, once I'm done solving that, then I am going to be dividing that amount against the liquidity pool supply, which is basically the value that will tell me the amount of tokens that I have in the staking pool, and the particular staking pool. Okay, so let's go ahead and like we have done with the other cases. Let me go ahead and move this to the side here. Beautiful. Let me go ahead and replace the values, okay? And we are almost ready to code the function and add that to the smart contract, okay? I am going to be passing account token per share. Don't know what that is. You know, let's assume this is the first time that we update the pool. So I'm just not adding 0. If the pool was already updated, then this will not be 0. It will be something else, okay? So what I want to do now, the token reward, I have to pass that value that we obtained, which was 440. We can see it right here, 140. And then we are going to be passing the liquidity pool supply, which in this case is going to be 70. And I add that in. And we go. There we go. Okay, so now let's solve this. Let's take the calculator. Solve this equation. What we're going to do first, we're going to be resolving this, but remember, 440, it's not, we should not be multiplying this as an integer because the value that we obtain total reward is way. It's not integer. I actually put this for 440 so then you understand how many tokens was that. But it's in way value. So we have to convert that to way. So let's do that first. Then we'll multiply it against the sample value, right? But we'll convert that into a factor of 12. We multiply the way and then against 1 to 12, factor of 12. Then we can continue here. This value, ladies and gentlemen, is also way. It's not integer, okay? Which means that I have to also multiply this against 118, okay? So let's do that. Let's add this onto way into modify. I'm just going to make it happen here. You make sure that you are aware this has to be in way, okay? We'll solve that first, and then we can continue, okay? So let's go ahead and fix that. Okay, so the first thing we're going to do, we're going to convert this back into way. 440 times 118. And this will be the value of way. Awesome. Now what I have to do is I am going to multiply this value now against the sample. So factor of 12, okay? I'm going to do, again, once again, 1d12. And this is the value now, okay? Awesome. Now let's go ahead. We know this is the value. Let me just put it aside. Just put it there. And now what I'm going to do, I'm going to convert the liquidity pool supply into Wave. Okay, so we're gonna do this. We're gonna do 679,924 times 1E18. Okay, and this is the value in Wave. Okay, now I have this, right? Copy it, pass it here because we're gonna be adding that together. We're gonna be dividing this value together. So copy it. Now we're gonna be doing this, pasting, and now we're going to be dividing against the value that we obtained. And sure enough, now we end up with 647,131,000. Remember, this is in Wave. Okay, this is value is Wave. So what I'm going to do, I'm going to copy this, right? Check this out. I'm going to go to a converter. Okay, we're going to go and paste this. And this, ladies and gentlemen, this will be the amount of tokens that I'm going to be paying per stake token. And you might say, well, this is a very low number. Well, there's a reason for that. Let's go back and show you. Grab this value, which paste it there. Well, there's a reason for that. We barely had blocks processed. Only 132 blocks processed. So we're not expecting to pay 1 or 2 tokens to that amount of stake tokens for only 132 blocks, right? That's why it's very low, okay? But that is the accurate value, okay? So what I'm going to do, I'm going to count token per share, and let's go ahead and create this, and this will be a count token per share. This value, ladies and gentlemen, it's the amount of tokens that I'm going to be paying. Each stake token, which is 679,924, staked during 132 blocks, or a range of 132 blocks, okay? Awesome. We saw the math. This is the entire math. Let me go ahead and go with this so you're not confused. This is the entire math. This is what happens in the update pool all along. Every time that we call update pool, this will be updated, okay? Let's build a function. Let's build this amazing function, which is very extensive, and we'll call it a day.
Go ahead and grab the code that we wrote in the beginning of the video. We'll add the code to the smart contract, and then we'll convert the formula into the Solidity code. Okay, we'll add that onto the update pool, and we'll call this a success. Okay, let's do it. So, first thing I'm going to be bringing onto the smart contract is going to be the modifier. Okay, so I'm going to go ahead and grab the modifier, and we will add the piece of code to the smart contract. Here, I'm going to copy this. Okay, so what I'm going to do, I'm going to add the modifier right after the constructor. Once we initialize the smart contract, the first thing I'm going to have is the modifier. So let me go ahead and zoom in a little bit. That should be good. Okay, awesome. So I'm going to add it here. Okay, let me bring the rest of the code. We should be good. Okay, awesome. So we have applied the modifier into the smart contract. Now let's bring the initial part of the update pool function. Okay, so what I'm going to do in that case, we're going to go all the way to the bottom. We are using the previous section file. Let's add the function to the end of the smart contract when we left it off in video number 3. And let's go ahead and paste the beginning of the function. So remember, we are validating the pool. Then we are going to take a look at the conditions. If the block number is less than the last reward block, you want to stop. If I don't have any tokens staked on the vault, then I'm going to obviously stop. But first, I want to make sure that I record the last reward block. Okay, so let me go ahead and grab the code. So what I'm going to do, I'm just going to copy some sections. I am lazy. I am definitely lazy. Should be typing it, but it works. Okay, so what I'm going to do, I'm going to say function update. Bring it up here. Let me scroll up. Update pool address. We're going to say PID. And then we'll paste the public, and we are going to invoke that modifier. Modifier is at the beginning of the code. So once we are done with this, I am going to add the other lines. Okay, so let's bring the other lines. We're going to add the storage map. I'm going to add it right here. Cool. Now I'm going to add the 2 conditions. Okay, I'm going to add this right here. Now we are going to be adding the 2 conditions. Let me copy this whole thing right here. And let me go ahead and paste it here. Okay, let me fix the indentation. So I'm going to say here, return. We're going to move this here. And we're just going to fix this indentation. And this return. And looking good. Looking good. Okay. Yep, that looks good so far. Okay, awesome. So now let's start by converting the formulas that we did manually in the whiteboard, and we're going to be adding those formulas onto the function, and this is it. Okay, so let's start. Let's go back and let me get the formulas. Okay, so the first formula that we're going to be adding is the multiplier. So what I'm going to do, I'm going to declare the variable, and then we'll add the formula there. So check this out. Check how this looks. Okay, so I'm going to go back here. Okay, so let's go ahead and add the multiplier. So what I'm going to do here, I'm going to invoke uint256 multiplier, right? And now we are going to convert this formula, block number minus last reward block, then the result will be multiplied by the bonus multiplier. Very simple. And for that, I have a function. Remember at the beginning of the video, we created a function that will allow us to get the multiplier. Okay, so that function will be called publicly. So what I can do here is I can invoke that function and pass the arguments. Like it's going to be the same. Okay, so let's do that. So you can see it right here. Get multiplier, right? And what I have to pass is the last reward block and the block number. Those are my two values, okay? So I'm going to copy this. I'm going to go down, and I'm going to go ahead and paste, and then we'll add those values. So the first thing that we have to pass is going to be the last reward block from the pool that we are interacting with on this function. So whichever pool ID I'm passing, I want to obtain the last reward block from that storage array, okay? So I'm going to copy that. I'm going to add that here, right? And then the second argument, the second parameter is going to be the block number, okay? So I'm going to go ahead and say block number, and that's it. That's how we get it. Once we pass those values, we invoke this function. If this function has a return, we should be getting the value back, okay? Okay, the next one. So let's build the next one. We are going to be writing the total reward. And this is going to be the amount of tokens allocated to the pool, okay? So let's go ahead and do that. We're going to be invoking uint256, total reward, and then let's go ahead and do the magic. We have to, as we mentioned, we're first passing the multiplier, then we have to multiply that by the n to the r per block, then multiply by pool allocation, then divide that by the total allocation, okay? So let's go ahead and do that. So I'm going to pass the multiplier, which I obtained previously, right? Right before that, I will obtain the multiplier. We'll pass the multiplier. Then we'll go ahead and multiply that. We're using safe math, remember? So it's going to be mul as a multiply. And we're going to pass that variable into the r per block. So it's right here. Awesome. Okay, we passed that. Now we have to multiply once again. Multiply. Now we are going to be passing the pool allocation, but it's the pool allocation for this particular PID, which means that I have to also call the storage and then grab the property. So the attribute that I want to get the information from, I have to invoke that based on the mapping that I just did, okay? So we know that each pool will have, I think, 4 values. So let's go back up, and we can see it right here. You got the liquidity pool token, allocation point, last reward block, and then reward token per share. Okay, so let's go ahead back down, and we're going to be passing the allocation point. Okay, so I have to call the pool first, right? And then we're going to say allocation point. There you go. Awesome. So let me go ahead and minimize this or zoom out a little bit because this is a long one. Okay, and finally, the last thing we have to do is we have to divide this by what? By the total allocation. Okay. So we're just going to type total allocation and bam, done. Okay, so we have the function to do the total reward, multiplier, multiply by the n to the r per block, multiply by the pool allocation, and finally multiply that by the total allocation. Beautiful. Okay, next, let's see what we got. Now we have the following. We got the total reward, right? But I cannot configure the developer fee because we haven't minted the tokens. Now, it's the moment, ladies and gentlemen, to mint those tokens. We are going to be invoking the function that is going to call the N2R token smart contract, and it's going to issue that mint request, okay? All right, so let's go ahead and do that. So as you know, we have to first invoke the N2R smart contract. How do we invoke the N2R smart contract? Well, you remember, if you were paying attention, we passed the N2R address right when we initialized the smart contract. Okay, when we deployed the smart contract, we bind it, we added that smart contract address. So I can use this variable and pass the function. Okay, so in this case, it's going to be mint. Okay, so N2R. So let's go back down. Let me see it right here. So we're going to say N2R, and we are just going to invoke mint. Okay, first thing that I have to pass, we're going to be passing the developer address. How do we find the developer address? Again, another thing that we provided when we deploy the smart contract, and it's currently stored in the smart contract, which means that this right here is the developer address. I'm going to be passing that to the mint function. Okay, so let's go down, developer. Beautiful. Now it's the amount of tokens. How do we determine that? Okay, let's go back. We said that we have to divide tokenReward by 10. Okay, so what I have to do is I have to pass this variable, then .div, which is divide using safe math, and pass the number 10. That's going to do the magic for us. It's going to solve this division. Okay, so let's go back. Let me go ahead and type total reward, and then we'll just divide this by what? By 10. If we want to provide 10%, it's going to be a fee of 10%. We're going to be providing 10% of the total reward. I'm not saying that we're going to take away 10% from the total reward and give it to the dev. No, because the stakers earn that amount. What we're going to do instead, we're going to mint extra tokens, and it's just going to be 10% of whatever we minted for the staking vault. Okay, beautiful. So done with that. Now we're going to do N2R. Now we are going to mint the tokens for the pool. We're going to be minting the staking rewards. Okay, let's check this out. We're going to do mint once again, but now I have to tell the token smart contract, where do you want me to send those tokens to? You know, once they get minted, where are you going to be transferring that? Well, guess what? To the Masterchef smart contract. Okay, so what we're going to do is address. And how do we tell the blockchain or the N2R token smart contract that I have to pass to the Masterchef smart contract? I just type this. That's it. That's how we tell that this particular smart contract is telling you, send me the tokens to me. Okay. And what is the amount? Total reward. That's it. That's all I'm going to be passing. Cool. There you go. So we have officially added the function that is going to provision. It's going to provide those tokens. It's going to generate those tokens, and it's going to mint those tokens and send that to the stakers, basically to the pool. Beautiful. So we're done with that, but we're not done yet. Okay, so what else do we have to make sure that we add onto the function? The account token per share. So we have to resolve that final function. So let's go ahead and write that function. And this will be our final one. Okay. Now we are going to be passing the pool allocation. It's going to be this one. It's going to be rewardTokenPerShare. That is the value that we provided on the last video, but it's literally the same. Account token per share, rewardTokenPerShare. It's the same thing. So first of all, I have to make sure that I'm mapping to the right location, which in this case is the pool that we are interacting with. And I'm going to just grab this value, right? And we're going to go down, down, down. We're going to say, first of all, I'm going to call the pool that we are working with. And now we're going to be passing rewardTokenPerShare. And now we're going to be resolving this, okay? What I have to do, I have to, once again, this variable right here is going to hold a value. So we have to make sure that whichever value it's here, we still apply that to the formula. So if there's a change, we grab what was previously stored, and then we calculate the rest. And if you go back into my whiteboard, you're definitely going to see that. I am re-invoking the same account token per share or reward token per share. Then I'm going to be adding the additional math functions or the math formula, okay? So make sure that's the case. Beautiful. So what I'm going to do, I'm going to copy this, paste it there. We're going to finalize the formula, okay? First thing we mentioned, we are going to be adding what are we going to be adding? Okay, so we need to add the token reward, and this will be converted onto Sabo. So we have to convert that value to Sabo. So let's go ahead and do that. So we are going to be adding token reward, right? And actually, I had a typo. So it's not total reward, it's token reward. I was about to screw it up. Okay, so it's not total reward, it's token rewards. Okay, so token reward, because I was like, why is it not auto resolving? And it was because of that. Token reward, and now we should be good. Now what I'm going to do, make sure that you don't do the same mistake that I did. Okay, now we are just going to multiply that by the Sabo, the value. Okay, and you're going to see once we do the stake function on the next video what we are going to do with the Sabo value. So that's where the trick is going to be. Okay, so we're going to do it's token reward that multiply once again, and now we are going to be passing 1e12. That's going to be the value that's going to be converted onto Sabo. Now, finally, what was the last parameter? It's going to be divided against liquidity pool supply. So let's go ahead and do that. So what I'm going to do is divide that by what? LP supply. Okay, and that's it, ladies and gentlemen. One thing that we are left to do in this particular function. Remember what I mentioned at the beginning of the video? The last reward block will be updated every time we run this function. Every time we interact with the staking pools, we will update the last reward block, which means that what I need to do, I am going to pass that last value right here. Okay, we're just going to make sure that we update the pool last reward block once again. Okay, and with that, we close the function. Boom. Okay, so let's take a look and see if we are missing something. Validate pool, pool ID. Let me control S. We are facing something. PID, address. It's not address. It's actually UINT256. Oops, my bad. Boom. Beautiful. Okay, so it's not address. It was UINT256. When I record videos, I am going in auto mode. Like I just continue coding and building the functions. And sometimes I don't realize that, oops, I declare this wrong. Okay, but it's UINT256, but it's very obvious. It's the number, the pool number. Okay, beautiful. So we have effectively added the update pool to the smart contract. We added the modifier. I am not going to be deploying this because we're not going to be able to test this until we get the staking functions. Okay, once we get the staking functions, ladies and gentlemen, it's go time. We have the smart contract ready to stake, unstake, and earn rewards. Okay, let's close it here, and we'll see you on the next video. Bye.